the 13th of August 2025. So this is the Shenwai 90 lathe. I must have it 40 years now anyway. This is the tailstock. And there's always a bit of maintenance on these things. And indeed, if you could get one of these and know how to improve it and put on the improvements I had, you'd have a great machine. It's always the little things that goes. Anyway, the tailstock has a quill. The part that goes in here is called a quill. And here is the handle for drilling and for manoeuvring the tailstock in and out. And just to show you how it works, there's a collar here, and there's a little, do you see the wee ball bearing in there? That wee ball bearing is to keep friction on the circular ring for measurement. Now, I don't know whether that ball bearing is clenched. It's held in by a spring. Is it clenched? And if it's not clenched and you take off this, the whole lot could come out. So I have nothing to gain by taking out that ball bearing, or taking the risk and it falling on the floor and searching for it. So that's going to go right back in. See that? Right back in. Now the next thing I do is I search or I check the calibrations here, and I find that there's 1, 2, 3, 4 calibrations, and it tells me here that each calibration is 0.1 of a millimeter. That's 0.1, 1/10 of a millimeter. Sorry, wait now. 1/10 of a millimeter, and there's 40 of them round. So it's 4. The lead screw is 4 millimeter pitch. So here's the lead screw, and I've measured the pitch with the tape, and every 10, it's a 10 of them is 40 mil. So it's a 4 millimeter pitch. I'm talking now about this here. See it? And there's the thread that's on it. There's a name on that. It's a big long name. I'll post it or something. But one of the things that I notice about this lathe is, do you see the ball bearings in here? So they went to the trouble, even though it's not as fancy as some lathes, they went to the trouble of putting ball bearings there to reduce the friction. And that's an admirable thing. This is an oil hole here. So the screw goes on here, you see, goes on there, and there's a little indent here because the pressure's not great. You don't need a key. That's all they need. And I treat that with great respect in case it would come out. I presume it's pressed, but I don't presume too much. So if you look in there, you can see the spaces. Maybe I'd find some way of removing that bit of shake, but I never mind backlash. That there is what's called backlash. Do you see that? Watch now. That little space is backlash. I've never found it a problem, but I might try and reduce it, and I might not. Usually when you screw on the wheel here, it'll tighten up that. Okay, enough said. Now the next thing is to show you what the problem is. This is the quill. And do you see the brass receiver, the internal thread? That's virtually gone. It'll let you drill lightly, but that has to be replaced. And it's brass. Now you can get them in steel, and you can get them in brass, and they can take a few weeks to order. So I have a little bit of thread left in there that'll let me out. Now if I can just show you the quill here. Here's the quill, and there's a piece milled. Quality of this machine is quite good. It'd do me. I wouldn't want any better. In fact, I nearly admire the people that made this in Taiwan. And then you have a Morse taper here. It's 2 Morse taper, which is adequate. I don't think 2 Morse taper is adequate in a milling machine. I'd like to have 3, but certainly 2 Morse taper is adequate, and you wouldn't believe the work that has done. It owes me nothing. So I bought at Cloghermart one of them, a Morse taper reamer, and I might give it a wee run when I have it out. The danger of touching that is that you'd put it out of true, that you'd knock it out of true. That's the word you use in engineering, true. So I'll be very careful there. So then you see the quill is calibrated here. So you can see how deep a hole you're drilling by twisting the wheel. Some people replace the wheel with a handle. I won't. I'm happy enough with the wheel. Now the thing is I've made a wee list here on this, and there is the thread. I've established the thread is 4 mil, happy there, but the diameter is 14.28. So that's strange. 14.28 is the diameter of it. So it could be that I won't be able to get one. If that's the case, we'll have to make one, and we'll have a bit of fun on that with an internal threading bar. A lot of work. If I can get it to buy, I won't do that. Now, so I'll be now looking to see, could that be an imperial? Would it be an imperial measurement? Sometimes you'll get that. It looks like 5/8. It definitely looks like 5/8. So we'll be figuring out what we do there is we divide 14.28 by 25.4, and that'll give you an inch measurement in decimals. Now wait, let me think, I'm not making that wrong. You divide it, millimeters, more millimeters than inches, so you divide 14.28, you divide it by 25.4, and that'll give us a decimal, and then you can convert that to fractions using trial and error and find out what it is. It has the look of 5/8 or maybe a 64th more. So once I establish the thread it is, I'll try then to source them, and they can be got certainly and the internet's great that way. So we'll be looking to source it if it can be bought. The next decision then is, should I use a steel one? And I think I won't, because the whole idea of the brass is the male thread stays okay. If I start using steel, there's a possibility of wearing it. But it could be all right, and sometimes I do replace them with steel. But the trouble is getting it out again. So you see that there's two pins here. So there's going to be a bit of fun getting them out. Now what I think I'll do is center punch them and get a reverse drill. Now I can't heat it hardly any because you distort it. So it's just ordinary, probably hardened and tempered steel. So I don't want to do that, but I'll try and drill them out with a left-hand drill. Probably, what would it be? Probably a 4 mil to start. Drill them out as far as I can. Now I don't know, are they tapped and threaded? I don't know. We'll do research on that, and indeed any of my viewers that wants to help, have a wee look round how they're done. This is the quill of the tailstock. So if I can get them drilled out a bit and horsed out, I can then put it in the 3-jaw chuck and cut out this altogether. Take this out down a piece. Now if I overshoot the runway and widen this a bit too much, well then that could be a problem. So there's going to be a wee bit of hacking on that. It's not just simple, but it'll be worth it. And meantime, I can use it because there's a bit of the thread left, but there won't be thread very long. Now, the other way would be to cut it out and put a very thin piece in here, having 3 pieces. In other words, you'd have the case, you'd have this old piece, and you'd have the new piece. The trouble is, how do you hold that in? There wouldn't be a problem making a plate to fit here. Making a plate that would fit with a hole there and a hole there. We'd say a hole there, and hole there, that they keep that in. But I don't think I can go too far wrong, because no matter what happens, I can always widen this out a bit. I hope I don't have to make one. But the lathe has 4 millimeter, no problem, a quick change gearbox and gear wheels. So I'll be able to do that. It's all about cutting down the labour. Okay, folks, comment underneath. The diameter of that is 14.28. There, it's there. And then I have also made a thing here of the threads. You see, I've done an impression of the threads just using the grease, the black grease. See that? So that I can bring that away and do a wee bit of measurements on that. Okay, thank you very much. Comment underneath. We'll see you back soon. Less than 10 minutes. Bye bye. Bye bye.